Hello and welcome. In this video we want to talk about digital things. We want to see what is digital. I mean, we're living in a digital world, everything is got to be digital and so on. But what exactly does it mean to be digital, to digitize our life, to digitize things? Therefore, we want to take a first look what means analog, to see the difference, to work a little bit out the difference between analog and digital. So what's analog? We'll draw a little picture here. If this is the real thing, so the measurement, here write measurement, just write measure, we measure a certain area, this is our measurement range. This is the measurement range. Okay. On the other hand, we have the display. And here we also have a display range. Display range. We also have a display range. Okay. And what would be perfect is that we do have this measurement range and this display range, and they fit perfectly together in some sort of line. So I have a line. For every value, regardless what this value is, for every value, measurement value here, I have here some measured value, 1. I have exactly one displayed value. Here, displayed value 1. Exactly 1. A measured value results by this line exactly in one displayed value. And on the other hand, I have a displayed value 2, and this must come exactly by this measured value 2. In both directions, I have a b-unique relationship. If I have one measured value, it's exactly one displayed value. If I have one displayed value, I have exactly one measured value to do this. So it is the displayed value is analog the measured value. There is no difference between. There's no difference between, and that's the analog world. Okay. In the analog world, every value has its counterpart on the other side. In the digital world, it looks a bit different. I also draw the line. I have some display, and I have some measurement. And of course, I again have my measurement range. Up to now it's the same. And of course, I have a display range. So far, no difference. Okay. Display range. And again, we can draw our lines which help us. And again, we would expect, okay, we have a relationship. We have a relationship between our display range and our measurement range, and this is again this linear. I will now draw it in dots. However, in difference to the analog world, I now divide the measurement range in a number of sub-ranges. Okay. There is a number of sub-ranges here. I'll just draw some. How many? I can choose. I simply pick a number of sub-ranges and I number them. I give each sub-range a number, a digit. This is sub-range 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is whatever, n, this is n minus 1, and so on. And this number is my displayed value. So I have such stepped line here, this case. Okay? So if I do have a measurement value, measured value 1 again, I will come up here and I have exactly this displayed value 1. Okay, that's still unique, a unique relationship. However, if I have, let's say, this displayed value, displayed value 2, I cannot say this is exactly one measured value. I only can say this is in this measurement range with the number 4 in this case. I cannot say if it was here or here or here or here. This is lost. This is simply lost. Here I divide my reality in chunks. It's a little bit like painting by numbers. I give each color a number, and in between, so let's say, I don't know, number 11 is light green and number 12 is dark green. There is no 11.5, a green in the middle. That's not existing. Okay? Exactly, that's the same thing with our digital world. There are only parts, there are only chunks, classes. And I just tell the number of the class the measurement value was in. In how many in how many sub-ranges I divide this thing here, yeah? How many I want to use, this I can select. Yeah? If I don't want to have these big steps, I simply use a smaller so-called resolution. I only do it, I double the resolution in my picture now. I make twice as much steps, yeah? And then it suddenly looks like this. Yeah? Here, 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 here. But I will never get rid of these steps. Yeah? That's the big disadvantage of the digital thing. It's a stepped approach. The big advantage of the digital thing is, and why we are using it, yeah? It is natively understood by computers. The computer is using numbers simply. That's it. Yeah. And it can calculate with this. And so the calculation or the use in the computer is much cheaper with digital values. And if I really need to have it finer, I can simply increase the resolution. Okay? So the resolution usually gives how many sub ranges in my measurement range I've got. Okay? In the analog world, I mean, the big advantage in the analog world is that I have a b-unique relationship between measurement and display. Yeah? But that's only in theory. Okay, that's only in theory, because in reality this line here is not a line, and is a little bit, because of friction and so on, is a little bit, let's say, blurry. An area. It's an area. And suddenly I have also here in both direction a range. Yeah? So that's the real thing is a little bit blurry. Yeah? It's not a fine line, it's a fat line. Yeah? If I want to narrow it down to a really fine line, yeah, then this gets really, really expensive. And this is the big disadvantage of the analog thing, is that if you want to have it really bi-unique, then this is expensive. Okay. So the plus points here are this bi-unique relation. Yeah. The minus points are, well, accuracy is expensive, and of course the transmission, yeah, information transition, information transition is not easy. Okay, if you want to get the information from one place to another place, the transition, I'm not sure, the information transportation is not easy. Okay. The digital world, on the plus side, it's much cheaper. Yeah. And the information can be accessed by computers, easily accessed. Yeah? And the disadvantage, of course, is the steps. Steppy, is this even a word? A steppy outcome. The steps in the outcome are the disadvantage here. I said, okay, resolution is how many sub ranges I'm using. Yeah? Usually the resolution is given in bit. Is given in bit. Yeah? What does this mean? If I have a resolution of 1 bit, yeah, this means just two classes, two subranges. If I have 2 bit, I have 4 subranges. If I have 3 bit, I have 8 subranges, and so on. Yeah? Quite usual, are 12 bit. This means then 4096 subranges. Okay. This is a very common digital resolution. Why? How we can get from this bit to how many subranges? This is based on the binary number system. Yeah, binary number system. That's the thing which is behind. There is, in the next video, I will explain numbering systems, and one part is also the binary number systems. But for now, it's just this to understand what's really mean it's digital. Yeah? So that we divide a measurement range into subranges. How many subranges we have is defined by the resolution. The resolution is given in bits, and the more bits, the more subranges, and it starts and it grows exponential. 2 raised by the power of resolution as the number of subranges. Like I said, why we will see in the next video. So thank you very much for listening for this topic now. Yeah, stay tuned. Thank you. Goodbye.